Alrighty, howdy folks. So let's look at basic trigonometric equations. I'm sure you're familiar with equations, right? Like if I say x plus 2 equals 5, solve for x. And so that x plus 2 equals 5 is, for instance, an equation. And oftentimes what happens is when somebody gives us an equation, the expectation is that we would solve that equation, right? Just as x plus 2 equals 5 is an algebraic equation, now we are going to look at what are called trigonometric equations. And there are some characteristics that are common. For instance, the question may be something like this. I'm showing consider sine 30 degrees for a different reason. I want to motivate this, but so what if someone said solve the trigonometric equation sine theta equals 1/2? Would that make any sense to you? Sine theta equals 1/2. It's kind of like x plus 2 equals 5, right? Something equals something. That's why it's an equation. Now, x plus 2 equals 5 has only one solution. X equals 5 minus 2, x equals 3. So 3 is the only solution that satisfies that equation. However, with trigonometric equations, we will see that there are more than one answer to all these equations, quite possibly. Sometimes there is no solution, but anyway, I'll show you all of that in just a second. Consider sine 30 degrees equals, so that's the first thing I'm asking you to do, is 1/2, right? Then what is sine of 180 minus 30 degrees? I'm taking the 30 degrees and asking what is sine of 180 minus 30? That is, what is sine of 150? Usually, we ask this question in the opposite way. Hey, find sine of 150 degrees for me. Or maybe I expressed it in radian. Like what is 5 pi sixths? Sine of 5 pi sixths. But here is the point. What is sine of 180 degrees minus 30 degrees? That is sine of 150 degrees. The answer is 1/2. What? If you recall, what did we say long time back? This quadrant system. First quadrant, second, third, and fourth. And in the first quadrant, all trig functions are positive. The mnemonic to remember is all students take calculus. And in the second quadrant, sine and cosecant, its reciprocal, are positive. T for tangent and its reciprocal cotangent. Again, C for cosine and secant, right? This is what we had learned. So that means if we figure out sine of, if we know that sine of 30 degrees is 1/2, we can be guaranteed that sine of 180 minus 30 degrees is also going to be 1/2 numerically. The only question for us is it positive 1/2? Is sine 50 going to be positive 1/2 or negative 1/2? That would be the question that we would have, right? And that's when we say, hang on, 180 minus 30 degrees, 180 degrees is this one, minus some 30 degrees should put you in the second quadrant. That is 150 degrees is clearly in the second quadrant where sine is positive. So the answer is sine of 150 degrees is also going to be positive 1/2. That's the big thing, right? The thing is, you already know this. I'm just trying to remind you of this. So going slowly. Good. What next? Now, what is sine of 180 plus 30? That is, what is sine of 210 degrees? Now, it will definitely be 1/2. The answer would be 1/2. The only question is positive 1/2 or negative 1/2, for which we will ask once again the same question, that which quadrant is 210 degrees in? The answer is in the third quadrant. And is sine positive in the third quadrant? The answer is no, sine is negative. Ah, cool. Then we are done. Sine of 210 degrees is negative 1/2. Cool. Now, one last question, I suppose. What is sine of 360 degrees minus 30 degrees? And which is sine of 330 degrees. The answer is once again has got to be positive, has to be 1/2. The only question is positive 1/2 or negative 1/2. And since 330 is in the fourth quadrant where sine is negative, the answer is negative 1/2. Cool. So this is something that you need to know so that you can learn to solve these trigonometric equations. Now, observe that the sine of four different angles have the same numerical value with perhaps only a sign difference. Would you agree with that? What is that? Observe that sine of four different angles, 30, 150, 210, 330. All four of them have the same value, 1/2, 1/2, 1/2, 1/2. The only thing is, some of them are negative and some are positive. Two of them are positive, two of them are negative. Cool. Now, let's see. That is, what can you say based on the fact that all these four angles have the same numerical value? Mathematicians are pretty clever about this. They use this concept of absolute value. Let me remind you, what is absolute value of 2? 2. What's absolute value of negative 2? Also 2, positive 2. What? Yeah, absolute value of negative 2 is positive 2. Okay, all right. So, absolute value of sine 30, that is absolute value of 1/2, is, because 1/2 is positive, is 1/2. Now, that's the same as sine of 180 minus 30 degrees, which is also 1/2. So when you take absolute value of it, you still get positive 1/2. Now here is the interesting part. Can I claim, please pay attention to this. Can I claim that this is equal to the absolute value of sine of 210 degrees? How can you say that, man, this is positive 1/2, but this is negative 1/2? Yeah, that's true. But notice, I'm taking the absolute value. Because of that absolute value, which turns this negative into a positive, it's perfectly all right to say that is absolute value of sine of 180 plus 30 degrees. All of them evaluate to 1/2, positive 1/2, including the sine of 360 minus 30 degrees. They're all equal to 1/2. Interesting, right? Good. I hope this made sense to you because we will need all this, and I'll solve quite a few problems demonstrating to you how we'll use what we just learned. Theorem. If theta is an angle in Q1, that is quadrant 1, then any absolute value of trig function of theta is equal to absolute value of trig function of 180 degrees minus theta, absolute value of trig function of 180 degrees plus theta, right? And so on. What? What's up with this trig, man? I know sine, cosine, tangent, and all that, but what's with this trig? Well, what I'm saying is, if you know that theta is an angle in quadrant 1, guess what? Any trig function, sine, cosine, cotangent, cosecant, secant, all kinds of things, they all have this property satisfied. That is, absolute value of whatever the trig function is of theta is the same as absolute value of that same trig function of 180 degrees minus theta, and so on. That's the key. Okay. Now, where trig is any trigonometric function such as sine, cosine, tan, etc. Cool. Now, example 1. Pick any angle, preferably something that we know the trig function values of. Say theta is 60 degrees. Is that a good angle? Okay, I hope you agree with me that theta equals 60 degrees is not a bad angle. Okay. Now, what am I saying? Let's interpret this theorem in light of this. Now, pick any trig function. You can pick any, but I seem to have some idea which one I wanted to pick. Uh, I didn't even realize I picked cosine. Say cosine. How do you interpret this? This means, then by the theorem, absolute value of cosine of 60 degrees must be the same as absolute value of cosine of 180 degrees minus 60 degrees, must be same as absolute value of cosine of 180 degrees plus 60 degrees, and so on. Cool? All right. And all of these are equal to 1 half, right? Absolute value. Key is absolute value. If you remove the absolute value, whoa, all bets are off. Some of them are going to be negative and will mess up our equal signs. Okay? Be careful about that. Now, those two background things were required because our intention, our objective in this section is to do this, solve certain trigonometric equations. I happen to choose sine theta equals square root of 2 over 2. What? Solve the equation. What in the world does that mean? What it means is find the value of theta or find the values, a plural, of theta such that sine theta equals square root of 2 over 2. That's called solving the equation. That what is called finding all the values of theta that would satisfy this equation sine theta equals square root of 2 over 2 is precisely what is meant by solving this equation. Okay? All right. Now, check this out. For this, I came up with a few steps. Step 1. For the positive value of the function, find the Q1 angle alpha. What do I mean by find the Q1 angle? Before I say what the Q1 angle is, for the positive value of the function, what I mean by that is, in your equation, you like we have here, sine theta equals, we happen to have positive square root of 2 over 2. Okay. But in some other problem, we could have negative square root of 2 over 2 or negative 1 half or whatever, right? Now, what I'm saying here is ignore that sign. If it's negative, just look at only the positive sign, positive value of this function. Negative square root of 2 over 2, just make it square root of 2 over 2. Think about that first. And for that positive value of the function, can you find the first quadrant angle? Meaning, sine theta, what value, because it's already positive, I'm asking, what is the angle for which sine of that angle equals square root of 2 over 2? And I'm sure you remember it's 45 degrees or pi over 4 radian. Good. So I'm going to call that not as theta yet. I'm going to call that as alpha because I'm going to use alpha in different ways to find all the different values of theta. That's the purpose of this angle alpha. So find the Q1 angle, first quadrant angle, for which sine of alpha is equal to positive square root of 2 over 2. And the answer is like I said, 45 degrees or pi over 4. So here sine theta happens to be already square root of 2 over 2, where square root of 2 over 2, the value of the function, is already positive. And so we can just simply jump to figuring out what that angle alpha is. So the Q1 angle, where sine of this is equal to square root of 2 over 2, like we discussed, is 45 degrees. So I'm saying, that alpha is 45 degrees, or in radian, pi over 4 radian. Cool. Now, this is alpha we solved. We didn't solve for theta. But check this out. Now, find the other quadrant or quadrants. The trig function will have the same sign and value. All I'm asking here is focus on just finding the quadrant in which sine theta is is again square root of 2 over 2. Which quadrant? This is positive square root of 2 over 2. Sine is positive in the second quadrant. So, the answer is the second quadrant. That's what I'm asking. Find the other quadrant or maybe quadrants that this trig function will have the same sign and value. Positive square root of 2 over 2. Again, same sign, positive value, positive sign, and the value of square root of 2 over 2. Cool? All right. And sign is positive in which quadrant? Second quadrant. So, step 3. Use alpha as a reference angle and find the other values of theta. See, now we are using this alpha to find not only the first quadrant angle for theta, but also the second quadrant angle. Okay, and look at this. So theta is pi minus pi fourths. Okay, pi minus pi fourths. Isn't that how we find we use the reference angle to find the second quadrant angle? Pi minus pi fourths is 3 pi fourths. Okay. Now, step 4. Use the period of the function to find all the angles. Wait, what happened so far? We got sine theta equals square root of 2 over 2 to be true for theta equals, in this case, alpha is 45 degrees or pi over 4, and for also theta equals 3 pi over 4. Is that it? The answer is no, 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 no. There is this concept of periodicity of trig functions. For example, if we recall the graph of sine, would you agree the sine has a period of 2 pi? What? How do you know that, man? Well, we talked about this, but if you forgot, that's okay. For me, a good way of figuring out the period when you have the graph is pick two identical points. Like for instance, the peak is here and the peak is here. That's why I'm saying they are identical. Okay. And measure the horizontal distance between those two. This peak is at pi over 2. The second peak is at 5 pi over 2. So the difference between them is 5 pi over 2 minus pi over 2. And that turns out to be 5 pi over 2 minus pi over 2 is 4 pi over 2, or in other words, 2 pi is the period of a sine function, right? Now, should I talk about this? Yeah, okay. It would have been so much easier to say, hey, wait a minute. Of course, the period is 2 pi, man. 0 to 2 pi. Ta-da! I agree. At 0, we have a y value of 0. And at 2 pi also, we have a y value of 0. So, simple, the period is 2 pi. 2 pi minus 0, which is 2 pi. Yes, I agree. But the stupid thing is 0 even at x equals pi. Right? That might throw us off a little and may somehow errantly we might say the period of a sine is pi. No, it's not. The period of sine is not pi. Period is 2 pi. And that kind of an ambiguity would have been avoided by picking the peaks, or you could have picked the troughs. Now notice, this is happening at 3 pi over 2, this bottommost point, and this is at 7 pi over 2. So 7 pi over 2 minus 3 pi over 2, you will find out, is also 2 pi. Cool. Okay. All that is to say, or to remind you, all that is to remind you that the period of a sine function is 2 pi. Why do we need that? We're going to use that to figure out the remaining angles of theta. Having gotten theta to be pi fourths, now we need to add plus 2n pi. What? 2n pi? What's up? Yeah, because, what's a good way? Square root of 2 over 2. And that is 60 degrees, 45 degrees, right? Okay, 45 degrees is pi over 4 is midway between 0 and pi half. So here. So some value over here is square root of 2 over 2. But then notice, can I add 2 pi to it? Yeah, if I do, where do I come? I land here. Isn't the y value square root of 2 over 2 even for this x value? Yes, for this angle theta or x, you can call it. And again, I can go 2 pi more and find another number. And I can keep on adding 2 pi, multiples of 2 pi, 4 pi, 6 pi, 8 pi, like that. And mathematicians simply say, that means you have plus 2n pi. What in the world is n? N is an integer. This is a standard way of doing things. Okay. And not only did we have pi over 4, to which we added 2n pi, we also had theta to be 3 pi over 4 using the reference angle concept. So to that 3 pi over 4, we'll add this 2n pi. Cool. That's it. Those, it will finish all the values. Now all the values of theta are the solutions of this equation, sine theta equals square root of 2 over 2. If somebody asks you to list a few of these, you could say pi over 4, comma, add 2 pi to pi over 4. What do you get? 9 pi over 4. Add 2 pi again to that 9 pi over 4, and you get what? 17 pi over 4, right? Something like that. So you can do that. Similarly, do the same thing for 3 pi over 4 plus 2n pi. That must have been a few steps, but if you need to go back and watch this portion again. I know there are 4 different steps and so much I talked about, but one good thing that I'll try to do for you is I'll use the same process and solve a few more problems so that the whole concept becomes crystal clear to you. Okay, let's see. Solve the equation sine theta equals negative square root of 3 over 2. Okay, what did we say? For the positive value of the function, find the Q1 angle, the first quadrant angle, which we are calling alpha. What do you mean positive value of the function? Look, we have sine theta to be negative square root of 3 over 2. So what this is saying is ignore that negative sign, just for the positive value, square root of 3 over 2. Sine of what angle in the first quadrant equals square root of 3 over 2? We all know that to be 60 degrees or pi over 3, right? So here sine theta is negative. So for positive square root of 3 over 2, we have the Q1 angle as alpha equals 60 degrees or pi third radian. That was exactly the same first step that we did before also. The only difference is earlier it was positive square root of 2 over 2. Now it is negative square root of 3 over 2. And like I said, you need to worry about only the positive value of the function first and find the first quadrant angle, which we did. Now, the next thing is just to find the quadrants. Where else, in which other quadrants would you have negative square root of 3 over 2 as a value for sine? Right? Negative. Well, there are how many quadrants would sine be negative? Would be, right? Let's not worry about the square root of 3 over 2 part, the negative part. Answer is sine is negative in Q3 and Q4, right? Okay. So, armed with that piece of information, we'll use alpha as a reference angle to find the other values of theta. We got alpha to be 60 degrees or pi third radian. And also, we know that we should be picking angles in the third quadrant and the fourth quadrant. And so, to do that, we'll use our reference angle pi thirds and say third quadrant angle you want. Okay, let me add a pi so that pi plus pi thirds is 4 pi thirds would be the third quadrant angle. Cool. Okay, how about the fourth quadrant angle? We use the same reference angle pi thirds, but to find the fourth quadrant angle, we need to do 2 pi minus this pi third, right? 2 pi minus pi third, 2 pi minus alpha, which is 2 pi minus pi thirds, which is 5 pi thirds. Cool. So the idea is guaranteed. Sine of 4 pi thirds would be negative square root of 3 over 2. Similarly, sine of 5 pi thirds will also be negative square root of 3 over 2, guaranteed. So we have found two solutions for this equation. But we know that we need to now make use of the period of that function, and so we'll make use of the period of the sine function to be 2 pi and add a 2n pi to both the values that we got here, for the two values we got above. Cool? If you notice, it's exact same procedure. All right, next problem. Tangent theta equals -1. Let's look at some different function, not a sine. What was the first step? For the positive value of the function, find the q1 angle alpha. Here, we have tangent theta to be -1. What did we say? For the positive value of the function, ignore the negative part. So for 1, right? So for 1, we have the first quadrant angle. What am I asking? I'm asking where is tangent of what tangent of what angle in the first quadrant equals 1? Answer is 45 degrees or pi over 4 radian, right? So alpha is 45 degrees or pi over 4 radian. Step 2, find the other quadrants. The trig function will have the same sign and value. Where would this be negative? Tangent? Remember, all students take calculus. Second and fourth quadrant, tangent would be negative. So tangent is negative in Q2 and Q4. Good. What's the third step? The key step. Use this alpha that we got in step 1 as a reference angle and find the corresponding values in Q2 and Q4. So for Q2, we say pi minus pi fourths, and for Q4, we say 2 pi minus pi fourths. Now that we got these two angles within in 0 to 2 pi interval, we'll figure out the rest of them by making use of the period of the function. Okay, what is wait, what? Use the period of the function. What function? Tangent function. What's the period of tangent? I don't know, man. Okay, man. You remember this is a piece of the a portion of this tangent curve looks like this, right? So based on this, you can see, you can look at this thing approaching infinity and approaching infinity. So 3 pi half minus pi half, cool, which is pi. Or we could say, it is 0 here and going up. It is 0 here and going up. Same thing. So 0 to pi. So pi is the period for tangent. Whereas for sine and cosine, the period is 2 pi. For tangent and cotangent, the period is pi. Cool. So what do we do with that? And so we'll make use of the period and add, because this is the, maybe I should put it in the form of a question. Now that we know that the period is pi for this tangent function, what should we add to 3 pi over 4? You remember? We added 2n pi in the previous case. In this case, what should we add? We should add n pi, right? N pi, not 2n pi, because period only happens to be pi for this tangent function. Okay. I'm such a liar. And I put a box around this as if to say somehow 3 pi over 4, 3 pi over 4 plus n pi, good, there's nothing wrong with that, n is an integer. But come on, man, what about 7 pi over 4 plus n pi? Right? The thing is, when you think about it, there was no need to have a separate thing called 7 pi over 4 plus n pi. This itself will automatically take care of that. What? How is that? Think about it. Okay. What happens if we, knowing that n is an integer, uh, is 0 an integer? Yeah. So make n to be 0, which means you are adding 0 pi. So 3 pi over 4 plus 0 pi is just 3 pi over 4 plus 0, which is 3 pi over 4. That's definitely one of the answers. Okay, now let's make n equal to 1. What happens then? Then we have 3 pi over 4 plus 1 pi or pi. What is that equal to? 3 pi over 4 plus pi. Turns out to be 7 pi over 4. Wait, that is this other angle. Yeah, that is exactly why we didn't have to include that 7 pi over 4 plus n pi as a separate case. The moment you pick this 3 pi over 4 and add an n pi to it, that automatically covers 7 pi over 4 and whatever n pi you add to 7 pi over 4. It's automatically covered. Right? That's an interesting question or interesting situation. Just be aware of it. Okay, next. 4 cosine square theta minus 1 equals 0. Whoa. What? 4 cosine square theta minus 1 equal to 0. This is looking very different from the previous ones, right? But the truth is, not a big deal. Why not? Because check this out. If I had given you a quadratic equation, 4x square minus 1 equals 0, could you have solved for x? What? 4x square minus 1 equals 0. Solve for x. I'm sure you would have easily, effortlessly done that, right? That's what we will do. By giving us the whole equation in this form, they are not telling us what cosine theta is directly. They are giving us that information in an indirect way. That's the key. So, what do? 4 cosine square theta minus 1 equals 0. How can we solve this? Well, that implies cosine square theta must be 1 over 4. What? How, man? I added 1 to both sides and divided both sides by 4. That's what I did. So, would you agree that gives us cosine square theta equals 1/4? That is the first order of business. But then we actually want to find cosine theta itself, not cosine square theta. From that, let's figure out what cosine theta is. Think about it. Okay. Sorry, I had to take a sip of water. Cosine theta is 1/2. Careful, careful. If x squared equals 4, x equals what? Would you say 2? Or would you say plus or minus 2? Right? So be careful here. Cosine square theta equals 1/4 implies cosine theta is plus or minus square root of 1/4. That is plus or minus 1/2. Aha. So what they're saying is, please pay attention to this. By giving the problem this way, what they are saying is, now solve the equation cosine theta equals positive 1/2 and cosine theta equals negative 1/2. Right? Both of them. What all values of theta will satisfy cosine of that theta to be positive 1/2 or negative 1/2. Right? Okay. I hemmed and hawed because and or what to use. Or is the correct one. Cosine theta is positive 1/2 or negative 1/2. Uh, yeah. Okay. So let's get busy. Let's do what we did before. And first pick cosine theta equals positive 1/2. So for positive 1/2, we have alpha to be, again, right? That's that concept of alpha. First quadrant, cosine of what angle in the first quadrant is equal to 1/2? The answer is 60 degrees or pi third radian. Good. Now, what did we do? The other quadrant where we have positive 1/2, cosine of that. Cosine is positive. Fourth quadrant, right? How do we find a fourth quadrant angle using alpha equals pi third as the reference angle? 2 pi minus pi thirds. So 5 pi thirds. Cool. So what are the two different angles theta that satisfy 1/2? Pi third and 5 pi third, right? Now for negative 1/2, what are the quadrants? Where is cosine negative? Second and third, right? Q2 and Q3. How do we find the Q2 angle? Q2 angle is always pi minus the reference angle. Q3 is pi plus that reference angle. So the Q2 angle is pi minus pi thirds, which is 2 pi thirds. And the Q3 angle is pi plus pi thirds, which is 4 pi thirds. So we have theta to be pi third, 5 pi third, 2 pi third, and 4 pi thirds. So we know 4 values of theta which satisfy this. And not only that, we'll use the periodicity concept. What's the period of cosine? Is 2 pi. So we'll add to every one of these a value of 2n pi. We take the pi thirds, add a 2n pi. 5 pi thirds, add a 2n pi, and so on. Cool. So that's how you solve a quadratic trigonometric equation. I think you can dazzle someone who's taking algebra and they are doing quadratic equations. Hey, my teacher taught us the quadratic equations today. Oh, dude, check this out. You just do quadratic equations. We do quadratic trigonometric equations. Oh my goodness, you must be a genius, man. Yeah, man. Okay. All right. Find all solutions. 2 sine square theta minus sine theta minus 1 equals 0. So like in the previous problem, our first attempt is to solve this equation, quadratic equation in sine theta. Kind of like had it been 2x square minus x minus 1 equals 0, would you know how to solve that? Yeah. So we'll do that. You don't do okay. So anyway, so it turns out that you can solve this quadratic equation as sine theta minus 1 times 2 sine theta minus 1 equals 0. What did I do? This is called solving a quadratic or factoring a quadratic using grouping method. That's what I did. Okay. Would you agree that minus sine theta is the same as minus 2 sine theta plus sine theta? If we add these two things, would we get back this middle term, minus sine theta? So that's what I did. I split this middle term, minus sine theta, into 2 as minus 2 sine theta plus sine theta. Why? Because when I do that, I know something nice is going to happen. If I group these first two terms, that is 2 sine square theta minus 2 sine theta, and then group the last two terms, sine theta minus 1, I can factor out something for the first group. What can I factor out? I can factor out a 2 sine theta. Good. When you factor out a 2 sine theta from the first two terms, what do we get? Sine theta minus 1. Right? You can check this. Distribute it. 2 sine theta to sine theta minus 1. You get back 2 sine square theta minus 2 sine theta, which is exactly what the first two terms are. Right? I'm just showing you the reverse process to show that, in fact, this forward process was actually correct. Now, plus we'll factor out a 1 from this. 1 times sine theta minus 1. What? Why did the good news is this way of splitting for helped us is, notice we have a sine theta minus 1 in the parenthesis here and the same sine theta minus 1 here in the parenthesis, which means we can factor out a sine theta minus 1 again from both these terms. And so when we do sine theta minus 1 times 2 sine theta from the first term minus yeah, what? I'm an idiot. We need to change this. This is sine theta crud plus 1. 2 sine theta plus 1. So sine theta equals 1 or negative 1/2. Samuel. Sorry about this, guys. I'm after all human. So for pi half, that takes care of this. And negative 1/2 would be third and fourth quadrants. So pi 6 plus pi. So that I have to make this into 7 pi over 6. And 2 pi minus pi over 6 is 11 pi over 6. And yeah, oh, man, I just went over this slide before I started recording. And I didn't realize that. Okay, sorry about that. So when you factor out, you get a 2 sine theta plus 1, and so sine theta equals 1 from the first, and 2 sine theta plus 1 equals 0 if you solve that. Would you agree? You subtract a 1 from both sides and then divide by 2, and you get sine theta to be negative 1/2. So corresponding to sine theta equals 1, we know sine pi half equals 1. Sine 90 degrees or pi half equals 1, right? And so pi half plus 2n pi, that takes care of all the angles for which sine theta equals 1. And the negative 1/2, 7 pi over 6 plus 2n pi, 11 pi over 6 plus 2n pi, where n is an integer. Cool? I think that's a good problem. Well, amigos y amigas, adios.